Welcome to our case study on how Minecraft ported realms to Azure. I'm Brian Trevathan, joined by my colleague Cullen Waters. Today we're going to go through a quick introduction of who we are. We'll talk very briefly about what is Minecraft Realms, and then we'll go over the three different major pieces of the migration process. So who are we? I'm Brian Trevathan. I'm a senior software engineer and a member of the PlayFab organization. I've had the good fortune of spending the entirety of my 13-plus year career at Microsoft as a member of Team Xbox.
And I'm Cullen Waters. I'm the principal software engineering lead for the Minecraft Realms service team. Unlike Brian, I did not recognize right away that I wanted to be an Xbox, and it took me a few years to get there, but I have had more than 10 years of joy as a Team Xbox employee.
Great. So, what is Minecraft Realms? Realms are Minecraft servers run in the cloud and managed by Mojang. The Realm service was built by Mojang prior to being acquired by Microsoft and thus was built entirely on top of AWS. At some point, the decision was made to migrate the service to Azure, and that's where we got involved. Now, the Minecraft Realm service can be split into two big pieces. There's service logic that's used to start, stop, and configure your game server, and this is your typical HTTP request handling logic. And then there's code to manage and maintain the machines that are running the game servers themselves. So the first step in our process was to migrate the logic for managing the machines that are running the actual game servers. We call this migrating game server hosting. So I'd like to do this by telling you a story about doing one of the most enjoyable things in all of software development. And it starts early in my career when I had a mentor who told me some of the best code you'll ever write is with the delete key. Deleting code is a magical feeling. The more you delete, the less code you have to maintain. And infrastructure code is some of the best to delete. It's super important, but is almost entirely invisible to your users. No one even knows it's there until it goes wrong and becomes this thankless job. So what follows is the story of our journey. Our journey to delete about 12,750 lines of code and config and happen to migrate clouds in the process. So let's meet the characters in our story. So you'll see on the left, we have 2 or 3 developers at Mojang Studios in Stockholm. On the right, we have a group of developers inside PlayFab called the Multiplayer Servers team. And right smack in the middle is me, the guy who's neither a Mojang Studios employee nor a member of the PlayFab Multiplayer Servers team, but rather is the engineer who's just trying to stick the two pieces together. So what did we get to delete? You can look on the left at where we started, and you'll see inside the big box labeled AWS, we've got both our service code and our game server hosted entirely on that cloud. You'll see that clients across all of our platforms communicate with front ends to manage their realm. You see that this is where they do things like change the name of the realm, set the difficulty, that kind of thing. Now, when a client wants to actually play their realm, their client issues a request to our front end, and our front end reserves a game server from a pool of standing by servers and returns its IP address and port back to the client. You'll see too that we've got a set of job agents that are constantly running and watching the state of that pool. They're allocating more VMs as load increases and destroying VMs when they're no longer needed. Additionally, the Realms team had authored custom code that runs on each of those VMs that are hosting the game servers themselves. This is represented by this sort of round bubble that says agent there on the multiplayer game servers VM. That agent is in charge of starting and stopping the Docker containers that are hosting the game servers themselves, as well as relaying messages from the front end and into those containers. So if we look on the right, this is where we ended. Now, this is not the state that we're in today. This is just the state we were in at the end of this portion of the migration process. So we'll see that we still have game clients that are interacting with front ends in AWS, but now those front ends are using PlayFab Multiplayer Servers APIs to reserve a game from the pool. And PlayFab Multiplayer Servers is now the one doing all the hard work to maintain that pool of game servers for us. It's elastically scaling VMs to host our game servers. So now when a player wants to play in their realm, again, their client's issuing a request to our front end in AWS, and that front end now, instead of interacting with our own pool, is making a simple API request to PlayFab Multiplayer Servers to allocate one of the game servers that's standing by and ready to go. So what this meant for us is that we no longer needed to maintain the code for that agent that we were running before. We were no longer relaying messages through that agent and into the Docker container, which eliminated a whole source of failures for us. No more jobs to scale up and down the pool no more monitors watching that code, and the best of all, no more alerts waking us up at night when that code starts to experience failures. So the great part is that getting started with PlayFab multiplayer servers is pretty easy. We take the game server development kit from PlayFab, pop that into our game server, then take our game server executable, upload that to PlayFab, and then just tell PlayFab how many game servers we can run on a single VM, how many instances of the game server we want to have available standing by in each of the different regions, and we're on our way. So how did we do it? So the first step in the process was to create this game server hosting abstraction. During the transition period, we wanted to be able to switch realms between clouds. This way we could easily fall back to our existing AWS infrastructure if something wasn't going well with our new Azure implementation. The catch is that the original code inside the front end certainly wasn't ever designed to be able to support running on different clouds and didn't have this abstraction in place for this scenario. So one had to be created. And then once the abstraction exists, then we need to go create two implementations of it, right? One for AWS and one for Azure. Now, what was interesting about this is our big goal here, our big journey is to go and delete a whole lot of code. But this process, paradoxically, actually required us to go write a whole lot of code. Now, fortunately, much of that new code we were writing, we got to delete, which is also fun. So it's kind of like we got to delete more code, but it felt a little bit like one step backwards. And the other thing to note is that while all of this conceptually is really easy and fits really nice on one slide, it actually represents a tremendous amount of work, and it didn't always go as expected, which we'll talk about in a little bit. So the second step in our process was migrating the actual world data itself. So migrating the hosting of compute for game sessions alone wasn't enough. Because the player's world is persistent, then every session on Realms requires that we retrieve the player's world data from storage and place it on the VM in Azure before the session starts up. Now, copying that data from S3 into Azure is, of course, going to be much slower than copying it from within the same data center. And since that extra time would increase the amount of time that players had to wait before they started their session, then it wasn't really a viable option. So we needed a way to move the player's data into Azure as well. So one option was to just bulk copy all the data. We kind of decided not to do that because bulk copying would have involved some amount of downtime since the player wouldn't be able to play their realm while their data was being copied. Plus, we probably would have needed to invent some kind of new system for locking realms while they're migrating and then unlocking them later, and that would have just been another source for possible bugs. So what we decided to do is what you see on the screen here. You'll see that pre-migration on the left, it was real simple. Server runs in AWS and it reads and writes data from S3. But during the migration, what we did is we said, okay, when this session starts up on Azure, what we're going to do is we're going to go look in Azure Blob to see if we have any data for this world. And if we don't, then we'll go read it from S3, bring it into Azure on the local VM, player plays their game, changes their world, and when their session is done, then we'll go take that data and put it in Azure Blob. Then the next time the player comes back, we do the same thing. We say, hey, do I have data in Azure? This time I do, so I'll just read and write that directly, and now I'm all done. So what this meant was that all active realms were sort of migrated automatically. Players did experience a small additional delay the first time they played their realm on Azure, but it was a small price to pay for this approach. This also had the additional benefit of spreading out sort of the load for the data migration. At no point did we have to go spin up a whole bunch of machines and create a whole bunch of compute in order to bring this data over quickly. We were able to sort of naturally spread that out over time as we sort of slowly migrated players onto this new infrastructure. The one downside with this approach that we sort of chose not to solve was the fact that we'd have a bunch of inactive realms that were still sitting around in S3. We knew this was a limitation, and it was something that we thought we could deal with later. And you'll actually hear Colin speak about how we handled this later on. So the third and final step in our process was updating a bunch of tooling. We needed to change our automated pipelines to take our game server executable, make it available both in AWS and in Azure. We had some other tools that are not leveraged by players, but are rather leveraged by our ops teams that still talk to S3 directly. And we sort of knowingly decided not to make changes there since they were not really part of the player experience and could still function just fine on S3, at least in the short term. So 3 steps, 3 slides. How long could it possibly take to do? Well, you can see that we started in July of 2017 and finished in about July of 2019. So our 3 steps and 3 slides took us 2 years to complete, which was pretty surprising. But as with any software project, we of course ran into unforeseen challenges along the way. So our challenges can kind of be broken down into 2 big buckets. We have human challenges and technical challenges. And I think the human challenge is actually the biggest one for us. I call it here, cloud migration is not fun. And the issue is that folks don't join a game studio because they really want to migrate their infrastructure. They join a game studio because they want to create fun experiences for their players. So we actually had a challenge just getting developers sort of mentally ramped up and ready to go on this project and really contributing 100% and making it their focus. So we solved this problem by shifting folks around until we really had a good team in place who really meshed well and worked well together. The catch is that this process really took us about a year before our team really started moving at 100% on this project. One of our big technical challenges was that PlayFab multiplayer servers was still being built. We were chasing a moving target. APIs were evolving and not everything existed when we needed it. Since it was a new piece of software, then of course bugs were prevalent. We tried to overcome this by just getting to know the people on both sides, by having the folks in Stockholm, getting to know the folks in the PlayFab multiplayer servers team, so that when problems did occur, then we could speak to the right person and get things resolved as quickly as we could. And then our last big technical challenge was the fact that prior to this, the Realm service didn't have much in the way of automated test coverage. So the introduction of that abstraction that we talked about for game server hosting and world data storage, that required a massive refactoring across the code base. And the lack of automated tests made it really difficult to ensure that our changes didn't introduce any regressions. So we had considered putting the entire migration process on hold, blanketing the service with tests, and then coming back and picking up where we left off. We ultimately decided that was a little too heavy-handed and decided to compromise and say, look, any new code we write's at least going to have unit test coverage so that we can try to prevent ourselves from getting in this situation again in the future. But for now, we're just going to move forward. And the result is that it was scary. And we unfortunately did introduce regressions and we did introduce outages, which was really unfortunate for us and for our players. So the end result, not only did we delete a whole lot of code that we used to have to maintain, but we also eliminated the burden of needing to worry about whether or not our infrastructure was going to be able to scale to meet our needs. Also, prior to the migration, we had been spending a pretty fair amount of money on AWS. And now we've shifted all of that spending to Azure, which just makes good business sense. And then most importantly, I think for this audience is that we provided a lot of early feedback to the PlayFab multiplayer servers team. We helped them to make sure that the workflows they were offering really worked for a large AAA title. We helped to validate that APIs were designed in a way that really worked for game developers. And we helped them mature their own internal processes to manage the needs of a AAA title. And hopefully all of that work that we did and all that pain we felt translates to a better service experience for folks like you. And then lastly, the relationships that we built between the Realms team and the PlayFab team actually ended up leading to the integration of more PlayFab features into Realms. For instance, now PlayFab is in charge of processing Realms purchases on some platforms. So that's how we handled game server hosting and game world data migration. Now I'll turn it over to Colin to speak about how we handled migrating the Realms service itself.
Thanks, Brian. So as Brian mentioned, the first thing that we did was move all of the game servers that are actually running in the cloud over to Azure through PlayFab. Then we decided to take on the next step, which was moving all of our service infrastructure over. So what did we move? We moved the service that handles about 20,000 RPS, requests per second, over HTTPS, handles many storage account operations, and has a significant amount of storage spread both through relational databases and through blob storage. So we split this up into 3 large categories. We move first our databases, then our compute, and then our storage. And you'll note that this is fairly similar to the way Brian and team approached the problem to begin with, where we identified large areas that could be moved independently of others. First, we chose to move our databases. Our approach for migrating our data from AWS over to Azure was to stand up duplicated infrastructure in both places. And then we used a process called Database Migration Service, a product in Azure called Database Migration Service, that was actually responsible for the replication between our Aurora MySQL instances in AWS and our Azure MySQL instances in Azure. DMS was amazing. It was incredibly helpful. I recommend it to anyone who's considering any project that requires moving data between two servers. Not only did it work flawlessly and continue to work for the entire process, the entire time that we were in this state, it was also free for the first 6 months. And as you'll see, that was more than enough time for our needs. Now, we stand our databases up behind firewalls, as I'm sure all of you do. And so we had to create a way for us to securely connect our AWS infrastructure databases to our Azure databases. We chose to use site-to-site VPNs to accomplish this on both the Azure and AWS side and configured them to talk to each other, which effectively connected our two clouds over a private connection. We contacted a team in Azure called Fast Track. Azure Fast Track is a team that focuses on helping customers migrate from on-premises or other clouds into the Azure cloud, and they were amazingly helpful. I can't recommend their services enough. We would not have been as successful as we were without their help. Now, speaking about our replication, I was concerned that given the volume of data that we process, we would have significant replication lag, and it would take minutes or hours in the worst case for data to move via the Azure DMS from AWS into Azure. In practice, though, our replication lag was usually less than 5 seconds. So next we decided we would connect our AWS-hosted front-end machines to our Azure databases, our Azure-hosted databases on the back end. And the intent here was that we could stand up side-by-side deployments and have our AWS-hosted front ends talk to our Azure backends as a single source of truth. We decided to approach this problem by creating yet another site-to-site VPN connection. This VPN connection went from our VPCs hosting the AWS instances in AWS to the VNet that hosted our databases in Azure. This worked really well in our test environments, incredibly well in our test environments. We had absolutely no problems. We did run into some problems when we went to production because our testing was flawed. We'll talk more about how to approach that and prevent hitting the same problems we did in a moment. Our intent here was to have a zero downtime migration. With both Azure and AWS front ends sharing the same single Azure hosted database, that gave us a single source of truth for all of our database information, which allowed us to have both front ends talking at the same time without presenting incomplete data or incorrect data. Now, I have a note here that says VPN SKU matters. And the reason I mention that is because most of the problems that we had in production were because when I set up this environment, I chose the default entry for the VPN SKU, and it turns out that didn't have enough bandwidth available to it for our needs. So when you're setting up a system like this, make sure that you pay attention to SKUs and that you choose a VPN SKU that is correctly suited for your size and for your needs. So once we had the database migrated, we started talking about how to migrate our service compute. Now, I make the distinction here of service compute to stand apart from the servers that we run. This is not the multiplayer servers, but rather the actual machines running our service code. So we went with the blue-green deployment model. We deployed a set of our services to AWS and a set to Azure. Both of them were talking to the same databases hosted in Azure. This gave us a lot of benefit. The biggest one is that we were able to stand up entirely duplicate infrastructure and test that infrastructure before we pointed customers at it. Because all of these Azure resources have internal URLs, we were able to, through host file manipulation and other mechanisms, point our local machines that the dev team was using at the Azure hosted front ends, which then talked to the same MySQL databases that the AWS hosted front ends were talking to, and allowed us to do all the internal validation we needed before we moved over. Now, from a functional perspective, we got 100% test coverage effectively. We were able to prove that the code that we deployed to Azure was fundamentally the same as the code that we deployed to AWS. We were able to prove that our service still worked when hosted in Azure. There are some trade-offs. The primary trade-off is that you have to duplicate your deployment infrastructure. So we had to write a bunch of code to deploy to Azure instead of AWS. Realistically, we were going to have to write that no matter what approach we took. But it also meant that we duplicated our cost. So we could scale down the instances in Azure dramatically to reduce cost, but we were still paying for Azure hosted instances at the same time we were paying for AWS hosted instances. And our intention was, once everything was up and running and we had fully validated it, we would use our DNS entries to cut over from AWS to Azure, leaving our AWS instances in place and ready to take over if we needed to cut back. And this is going to become important in just a few minutes. So next we had to talk about world data. Brian touched on the fact that when we migrated our server compute from AWS to Azure, we left behind world data for inactive users. And so you think to yourself, well, how much data can that really be? It turns out for services that have been around for a long time that host game worlds that are entirely sized based on user action, these worlds can be rather large. We had 300 terabytes of unused inactive world data left over in AWS after the previous team had the brilliant idea to migrate things as customers were impacted, as customers started to access it. And I do say brilliant because it really was a stroke of genius to move that way. It let us have a way to have customers move over when they were ready to use their stuff instead of when they weren't aware of it. And it gave us an easy way to cut back over. So what do we know about this data? In addition to it being 303-ish terabytes of data, it was spread over 13 million individual blobs in AWS. We chose to use AZ Copy, which is a tool that Microsoft produces to do this move. AZ Copy both supports AWS and now has a couple of extra examples for specifically the use case that we hit because I submitted the PRs to get them in. Our terms of service did not allow us to delete customer data. This is a thing that we've been working on to try and get rid of the long tail of having to keep data forever, but it's not an option for us today, so we had to move it. So what we did was we used AZ Copy and a bunch of VMs in Azure to run multiple AZ copies at once to get enough parallelism. It took us about a week to copy the 13 million files across from AWS to Azure. Then we ran a database update to change the location of all of these files from the AWS instance, AWS S3 bucket to their Azure blob storage account equivalent. And then once we were done with all of that, we were able to clear the buckets out of S3. Now, our initial thought was to go delete the buckets out of S3, but I got scared. I didn't know exactly how our code was going to be dependent on whether or not those S3 buckets were there, and I wasn't confident that we were going to be able to handle 404s if we requested a bucket that didn't exist. So rather than delete the buckets themselves, I emptied the buckets, which gave us an opportunity to not find out if we had bugs hiding, waiting for us. Along the way, we picked up a few battle scars. I think it's valuable to talk about these both as a lesson for other folks and to recognize that we're all just human and we all make mistakes, and that's okay. Our production database migration failed twice, and I take full responsibility for this. It was my decision to move it. It was my decision on the timing, and it was my failure to identify the performance gaps that we had that led to this problem. We found that MySQL 5.6, the community edition, which is what is roughly run in Azure, versus AWS Aurora has some pretty significant performance differences. We also hit a bug in Azure MySQL 5.6, which has since been fixed because we partnered with the Azure team to fix it. So before we went for a third attempt, we decided that we were going to upgrade MySQL from 5.6 to 5.7. This was a significant undertaking. We upgraded both in AWS and in Azure to ensure that our upgrade pipeline made sense. Then we moved everything over. Once we finished this upgrade, our performance was amazing, significantly better. I highly recommend, if you're going to be doing a similar migration, that you move to at least MySQL 5.7 first. Once we had databases all up and running and we were ready to cover, and we cut over from our AWS instances to talk to our Azure hosted databases, we ran into a couple of problems, the most significant of which was a VPN failure. We found that there are some fundamental disconnects between the way AWS and Azure handle site-to-site VPNs. And so I can't recommend using a VPN for moving your production data actively while you're actively using it. It worked great for the replication phase, but sending all of our production traffic, all of our production database traffic over the VPN was too much for it. You know, 303 terabytes is a lot of data. It takes a long time to copy. As we mentioned, it took a week to copy, and that was with 8 or 9 VMs running copies continuously through that entire time. It also cost significantly more than we expected. We found that ingress and egress on each cloud provider, in addition to having the data duplicated for some period of time, meant that we spent about twice as much in storage in AWS the month that we did the movement than we had for about 6 months prior to that. And we suddenly had a bunch more Azure spend in storage. So do be aware that as you're moving data from AWS to Azure, it's going to cost more for storage than you've used before, and you need to plan for that in your budgeting. We learned that Azure is very .NET centric. And if you're not using .NET, you should be prepared for some surprises. Specifically, we ran into an issue which has since been solved in Redis on the Azure side, where they did not expect the connection mechanisms that the Java library we uses to access Redis. And that caused significant amount of time to be spent handling connections and dealing with operating system overhead. Again, they've already fixed this bug, but I expect there are other bugs out there because Azure is really designed from the ground up for .NET. So what went well? We had some battle scars, but some stuff went really well. Azure Fast Track, I can't speak highly enough about them. They were awesome. They stepped with us. They stayed with us for every step of the way. They partnered with us. They helped us design a solution that would work for us, and they still help us out. I actually spoke to our Azure Fast Track rep this week about a really minor issue. Azure DMS was amazing, and you can't be free. 6 months of free time is pretty great. We used a total of 3 DMS servers to move all of our databases, and it was wonderful. MySQL 5.7 is a big upgrade from 5.6. We were able to reduce our database costs dramatically. The upgrade to 5.7 freed up so much performance that we were able to lower it by several SKUs. AZ copy was amazing. It just worked. I ran 9 different AZ copies in different VMs that were hosted in Azure. They ran for up to a week, and I had no failures related to the tool. And then the last thing is Azure Private Link. This is a technology that allows you to create tunnels, if you will, to connect from different VNets or different VPCs into your Azure MySQL database and other resources over effectively an internal VPN. It works wonderfully and gave us a huge amount of connection flexibility as we were accessing our databases both from AWS and from multiple VNets inside Azure. So a few parting thoughts. When we approached this project, as Brian mentioned, nobody signed up for the game studio to join a game studio to do this kind of work. It was hard. It took a lot longer than any of us expected, but it was absolutely doable. No one on our team had any experience of moving cloud providers prior to this, and we were able to accomplish it, which means you can too. Brian and I worked with our partner teams inside Microsoft to help resolve some of the issues that we hit so that customers and other folks won't hit them when they do their migrations. You should be prepared and help prepare your non-technical folks for the additional costs during the migration period. You're going to be paying for extra resources, and you may have to pay for extra things like storage costs. It is very, very likely that you will need to make some code changes during your move. We did not expect that our service was very aware of the fact that it ran in AWS, but what we found was there were a lot of places that the knowledge of the fact that we were running in AWS had kind of crept into the code. So expect to be able to change, or expect to need to change some code to move. Unless you can move your service into a read-only mode, you'll need some amount of downtime to cut over. At the very least, you'll need that few seconds for DMS to drain and replication to finish so that you can move everybody over to the Azure hosted DBs. And as we mentioned, migrating everything takes a long time. We're about 95% complete with our migration now. That last 5% I expect is going to take us at least another 6 months. It's going to take a lot longer for us to get from 80% to 100% than it did to go from 0 to 80%. And that's just because the return on investment starts to not make as much sense. And so we deprioritize that work for other things. Thank you so much for coming to our talk. Thanks for listening to our story and hearing about the challenges we faced and the successes we had as we moved Minecraft Realms from AWS to Azure.
Yes, thanks for coming and hope you have a great GameStack Live.